All right, so for today's lesson, we are going to talk about the wave. Now, in order for us to graph the wave, we're basically just graphing polynomials, but we need to find something called the solutions, which are our x-intercepts. So basically, we're just solving a polynomial equation, working with those x-intercepts to just form or sketch our polynomial function. So I'm going to go ahead and start off with number 1. So we have 3 terms, they're set equal to 0. What we have to do is determine whether or not we have a GCF. We don't. So we're going to go ahead and proceed with the x method. 9 goes up top, 6 goes down below, and the two numbers are 3 and 3. So I have x plus 3 times x plus 3, but don't forget, this is a polynomial equation. We have to make sure we set these two things equal to 0. All right, so then we have x plus 3 equal to 0 and x plus 3 equal to 0. So then we have x equals negative 3 and x equals negative 3. So notice that we have x equals negative 3 twice. We need to make sure we identify any multiple roots. So since x equals negative 3 appears twice, I have to indicate that this is a double root. So x equals negative 3 double root. Number 2, does this thing have a GCF? Yes, so we have to say the GCF here is x. So I'm going to factor that out. So x times x squared plus 3x minus 4. And now I'm going to focus on the stuff inside the parentheses. That's where I'm going to use the x method. Negative 4 up top, positive 3 down below. 4 and negative 1 are the two factors. So then I have x times x plus 4 times x minus 1 equals 0. So let me go ahead and move this to the right a little bit so I have some space. All right, so x times x plus 4 times x minus 1. So what do I need to do? I need to set this equal to 0. I need to set that equal to 0. And I can't forget about this little x, right? That x is just a variable, and I can set that equal to 0. So x equals 0, we're good to go. We don't need to solve. That's one of our roots. X plus 4 equal to 0, that's x equals negative 4. And then x minus 1 equal to 0, that's x equals 1. So if this helps you, the highest degree is 3, so therefore you should have 3 solutions, or 3 x-intercepts, right? So x equals 0, x equals negative 4, x equals 1. Number 3. So remember, we need to figure out the GCF. Is there a GCF between these 3 numbers? Yes. So I'm going to say 2x squared. So I have 2x squared times x squared minus 8x plus 12 equals 0. I'm going to go ahead and factor the stuff inside the parentheses. So our a value is 1, which is great. So 12 up top, and then negative 8 down below. We have negative 6 and negative 2. All right, so we have 2x squared times x minus 6 times x minus 2 equals 0. So x minus 6 equals 0, x minus 2 equals 0, and then 2x squared equals 0. So we should have 4 answers because the largest degree is 4, so therefore we should have 4 roots. So x minus 6 equal to 0 is x equals 6. That's one of our roots. X minus 2 equals 0 is x equals 2. That is another root. And then here we have 2x squared equal to 0. We need to make sure that we get the x squared by itself, okay? So let's see what I can do here. I just want to have a bit more room to do this. All right, so I got to divide both sides by 2. So x squared is equal to 0. And here, x squared, right? That's another way of saying x times x. And you're just going to set that equal to 0. So this x can be 0 and this x can be 0, right? So I'm going to write x equals 0 and x equals 0. So we have x equals 0 2 times, right? So if x is equal to 0 2 times, that means we have a double root. Okay, so we have 2, 3, 4. We should have 4 roots, all right? Let's move on to number 4. Okay, there's no GCF, but I noticed that 9x squared and 25 are perfect squares separated by a minus sign. So we're dealing with a difference of 2 squares, okay? So DOTS, dots. So we should have 2 sets of parentheses, 1 plus, 1 minus. So we have 3x, 3x, 5, and 5. All right? So are we done? No, because this expression here is set equal to 0. So I need to do 3x plus 5 equal to 0 and 3x minus 5 equal to 0. So I have 3x equals negative 5 and x is equal to negative 5/3. All right, so that's our first root. And then 3x equals 5 and x equals 5/3. And that is our second root. So I don't write a double root because both of these numbers are different in terms of signs, right? We have one negative, one plus, so they're not double roots at all. So this little 2 does tell me that we have 2 solutions, all right? So this is a good warm-up because what we're going to do is use these little roots to set up our polynomial functions. Okay, so the next thing that we're going to do is graph polynomial functions. We have a little example here to basically show us what a polynomial function looks like. So here we have something called a quartic polynomial, meaning it has a degree of 4. What we need to know, or some things that are important, is that it has x-intercepts, right? So it has an x-intercept of -3, x-intercept of 2, and x-intercept of 5. So again, these are our x-intercepts, and sometimes we call them zeros, right? They're basically the same thing. So this is where the line touches the x-axis. So this here, that little line in blue, that's our x-axis. All right? Okay, so those problems that we did above, that's important because we needed to find those solutions, those x-intercepts or zeros, right? That's our first major step. Now, the second step here is to determine where the line is positive or negative. So again, we have our x-axis here, and you can see the line is positive here and there, right? Because those little ends are above the x-axis, which means those two things are positive. So those ends are positive. Whereas this portion here, that's below the x-axis. So that is where the line is negative. So again, what we're trying to do here is find those x-intercepts and determine where the line is positive or negative. Okay? So how does this, all play out? Well, let's go ahead and start over here. So I'm going to use my laser pointer. I'm going to start over here. We are going to start, up top, positive, right? So as I approach the x-intercept of 5, Well, that is a single root. So whenever you have a single root, you're able to cross over the x-axis just like that. Now I'm going to approach the x-intercept of 2. Now notice that the x-intercept of 2, I don't cross the x-axis. In fact, it bounces just like that. Whatever an x-intercept bounces, that means you have a double root. So that x equals 2, that appears twice. So that's a double root. Therefore, it bounces just like you see on your screen. Now I'm going to go ahead and approach x equals -3, and you can see that it's going to cross, right? So x equals -3 is a single root. It's not a double root, so I can go ahead and cross the x-axis. Okay, so these are positive, and this portion here is negative. So let's go ahead and do some examples. So we have f of x is equal to x plus 2 times x plus 4. So you need to solve for this equation, meaning that this f of x, or that y value, must be 0. So 0 equals x plus 2 times x plus 4. So this is already factored for us. I don't really need to do anything else besides setting these two things equal to 0. So let's go ahead and do that. I have x plus 2 equal to 0 and x plus 4 equal to 0. So when I solve for this first equation, x is equal to -2. When I solve for the second equation, that's going to be x is equal to -4. So these are critical points. And this right here, that little picture that you see, is our x-axis. So let's go ahead and put our, x values. We have -2. Just kidding. That's going to be -4 and -2, right? It has to be all in order, okay, from least to greatest. So what do I do from here? Well, remember, the first thing that we had to do was figure out our x-intercepts. Now, the next thing that I have to do is to figure out where the line is positive or negative. And this is where the wave chart or the sign chart comes into play. So what I'm going to do is draw a little chart involving the x and y values. Okay, so we have our two x values already. We have -4. We have -4 and -2. So if I plug in -4 into this function, right? So if x is equal to -4, well, we have -4 plus 2, that's -2, and then -4 plus 4, right? So -4 plus 4 is 0. So -2 times 0 is 0. So I'm going to go ahead and put 0 for my y value, right? And that should be the same thing if you plug in x equals -2. Because those are our x-intercepts, where the line touches the x-axis. It should be in the form x comma 0. All right, so the next thing that I have to do is figure out what's going on to the right of -2, between -4 and -2, and what's happening to the left of -4. Okay, so we are just going to plug in x values just to see where the line is located each time. So if we start over here, all right, so let me go ahead and highlight this portion. Where is this line going to be? Is it going to be positive? Is it going to be negative? Well, we need to figure that out. So what number comes to mind if we think of left -4? Well, -5, right? So -5 is an x value. It's before -4. So what happens if I plug in -5? Well, we have our little function here, and we're going to plug in -5 into each x value. So -5 plus 2, right? So -5 plus 2 times -5 plus 4. All right, so -5 plus 2 is -3. So I'm not going to write -3. I'm just going to write a negative sign. Because again, I'm only concerned about whether this line in this area is positive or negative, right? So -5 plus 2 is a negative. And then we have -5 plus 4 that's also a negative. So I have a negative times a negative, which means we have a positive. So over here, this is where the line is going to be positive. We're already good with -4, right? X equals -4, it's going to be 0. So what we need to do is figure out what happens between -4 and -2. Okay, so let's figure out a number between -4 and -2. I'm thinking -3. So I have -3 plus 2 times -3 plus 4. -3 plus 2 is a negative, times -3 plus 4, that's a positive. A negative times a positive is a negative. So between those two values, that's where the line is negative. All right, so at x equals -2, it's going to touch 0. But what happens to the right of -2? Well, a number that comes into mind is -1. So we have -1 plus 2 times -1 plus 4. -1 plus 2 is a positive, times -1 plus 4. That's a positive. So a positive times a positive is a positive. Okay? So that's where the line is positive. Okay? So let's go ahead and put points on -4 and -2. So to the left of -4, we know it's going to be positive, right? Between -4 and -2, that's where the line is negative. And to the right of -2, it is positive, right? So our little rules really do help us sketch our polynomial function just like so. Okay, let's do another one. So here we have f of x is equal to negative times x minus 5 times x minus 2. So this is already factored for us. So all I have to do is write x minus 5 equal to 0 and x minus 2 equal to 0. So x is equal to 5 and x is equal to 2. So our x-intercepts are 2 and 5. All right? And then I'm going to go ahead and draw my wave chart. So x, y, we have positive 2, positive 5. Okay? So to the left of 2, I'm thinking 1. Between 2 and 5, I'm thinking 3. And to the right of 5, I'm thinking 6, right? So we're thinking of these x values. We're trying to figure out where the line is positive and negative. So if I plug in 2 and 5, of course, those are our x-intercepts, so the y value should be 0. If I plug in 1, well, we have a negative, right? So that negative, you need to make sure that translates over. Negative times 1 minus 5 times 1 minus 2. So we have a negative right off the bat times that 1 minus 5. That's a negative times 1 minus 2. That's a negative. So a negative times a negative is a positive. So a positive times a negative is a negative. For 3, we have a negative times 3 minus 5 times 3 minus 2. So negative times 3 minus 5 is a negative. And then 3 minus 2 is a positive. So a negative times a negative is a positive, right? Times a positive is a positive. And then for 6, we have a negative times 6 minus 5 times 6 minus 2. So we have a negative times a positive times a positive. So a negative times a positive is a negative times a positive is a negative. Okay? Now if we look, we're going to start negative, right? Before the x value of 2, this is where the line is negative. But between 2 and 5, that's where it's positive. And then to the right of 5, right, we plugged in the 6. We notice that the line is negative. Okay? So we should be good to go. Let's take a look at number 7. So f of x is equal to x minus 6 quantity squared. Now, we all know that if you have something like this, it's basically f of x equals x minus 6 times x minus 6. It's just x minus 6 2 times. So I can go ahead and write x minus 6 equals 0 and x minus 6 equals 0. So x equals 6, x equals 6. So since x equals 6 appears 2 times, we have to indicate that that is a double root, okay? So I'm going to go ahead and write 6, all right? And then I'm going to go ahead and do my wave chart or my sine chart. It should be really quick with this one. We have an x value of 6, so the y value is 0. Now, before 6, I'm thinking 5, and to the right of 6, I'm thinking 7. So I'm going to go ahead and use this one instead of this, just to be explicit, if that helps some people. So I have 5 minus 6 times 5 minus 6. That's basically a negative times a negative, which is a positive. And for 7, we have 7 minus 6 times 7 minus 6, which is a positive times a positive, which we all know is a positive, right? So if we start to the left of 6, we know for sure we have to start positive.
And then we bounce off 6.
And then positive again to the right of 6, okay? So as you can see, that 6 is a double root, so the line is going to bounce off the x-axis, just like so. All right? So that's what I mean when we went over this little example. You can see that it's going to cross at x equals 5, but as it approaches x equals 2, it's a double root. It's going to bounce, and then it's going to cross x equals negative 3, just like that, because x equals negative 3 is a single root. All right? Now, if you think the process of doing this is long, then what we're going to do is I'm going to show you a faster way of doing the wave. So moving on to the back side of this page, we have something called the wave rules. So if the degree of the polynomial is even, the ends of the graph will point in the same direction. If the degree of the polynomial is odd, the ends of the graphs will point in the opposite direction. So what do I mean by degree? So if I were to give you an example, let's say I have x cubed plus x squared plus x plus 5. Well, the degree of this polynomial expression, or maybe an equation if you're dealing with an equation, is we look at the largest exponent between all of these terms. And the largest exponent here is 3. So the degree is 3, okay? Now, if the leading coefficient is positive, the wave starts up on the right. If the leading coefficient is negative, the wave starts down on the right. And when I talk about the leading coefficient, I'm talking about the number that is attached to the variable with the largest exponent, or with the highest degree. So in this case, if we're going back to this polynomial expression, Well, this here, that variable with the largest exponent, has a leading coefficient of +1, right? So the LC is +1. Now, if I were to give this expression a negative x cubed, well, that negative is attached to the variable with the largest exponent, right? So in this case, the leading coefficient is -1. So that is what it means to be a leading coefficient, if that makes sense. Okay, so let's go ahead and move on. If the multiplicity of a 0 is odd, the wave will cross the x-axis at the 0. If the multiplicity of a 0 is even, the wave will bounce off the x-axis at the 0. So bounce off the x-axis at the 0. So multiplicity of a 0. So if the multiplicity of a 0 is odd, so in this case, those are my, single roots or triple roots, right? So if you're solving a polynomial function and it has x equals 5 and x equals 5 appears once, the multiplicity of that 0, that x equals 5, is 1 and it's still odd. Now, if the multiplicity of a 0 is even, then we bounce off the x-axis, right? So if you have like x equals 7 twice, right? X equals 7 and x equals 7, that's our double root. Well, that 0, that x equals 7, the multiplicity is
2, and it is even.
Okay, and it will bounce off the x-axis at that 0. So we're going to follow all of these rules. And starting off with 8, we have f of x is equal to negative x times x minus 2 times x plus 3. So you're going to solve for this, function here. You're going to solve for the zeros. So we have negative x, right? So negative x equals 0, x minus 2 equals 0, and x plus 3 equals 0. So here, if you have negative x is equal to 0, then x is equal to 0. If you have x minus 2 equals 0, x equals 2. And if you have x plus 3 is equal to 0, then x is equal to -3. So here are my x-intercepts, which I can go ahead and put on the x-axis over here. So remember, when we're putting stuff on the x-axis, we need to make sure that they go from least to greatest. So I'm starting off at -3, then 0, then 2. Okay? So we have x equals 0. That's a single root. It's not a double root. So we know we're going to cross. X equals 2 is a single root. So we're going to cross. And then x equals -3 is a single root. And we are going to cross when we do the wave. So the next thing that we have to do, and we're going to use this box this time, is figure out how the function behaves. So I need to go back to this thing over here, and it says if the degree of the polynomial is even, the ends of the graphs will point in the same direction, which means you can have something like this or something like that. So both of these ends point up and both of these ends point down. If you have a degree of a polynomial that is odd, the ends of the graph will point in the opposite direction. Okay, so you can have something like this, or that. So it looks like a disco dancer, right? So here, opposite directions, and here, opposite directions. So this is pointing, down here and up there. So it's down, up. And this is pointing top up here and pointing down right there. So this is up, down. Okay? So one thing that we have to do when we figure out our end behavior is determine the leading coefficient. All right? So the leading coefficient of this polynomial expression has a negative, right? So our leading coefficient is -1. And if the leading coefficient is negative, the wave starts down on the right. So it's going to start down on the right. The next thing that I have to figure out is the degree. So going back to my polynomial equation, well, I can FOIL this thing and figure out the degree of this polynomial function. Or I can just multiply all of these x's. So I have -x, x, and x, right? So I can do -x times x times x, which is -x cubed. So the degree is 3, and we know it's odd. So if the degree of the polynomial is odd, then the ends will point in the opposite direction. So notice that we have down right, so that means in the opposite manner, we have something like this. So that would be top left, okay? So your end behavior should look something like this, okay? Now, what we're going to do is we're going to sketch the wave of this function. Now, whenever we apply these rules, we always have to start on the right. If you use this process, it doesn't even matter. You're just following the wave chart. But here, whenever you use the wave rules, if you want to make your life easier, you have to start on the right. Now, the question here is, where on the right? Do you go above the x-axis or below the x-axis? Well, since the leading coefficient is -1, we need to start on the right, and it needs to be below the x-axis, right? So here, I need to start below the x-axis and then begin doing the wave. Now, here are my zeros, okay? So all of these zeros, or my x-intercepts, are single roots. That means I can cross the x-axis each time. So let me go ahead and start over. I'm going to start, bottom right. And as I approach 2, I'm going to cross the x-axis. And then as I approach 0, I'm going to cross the x-axis. And as I approach -3, I'm going to cross the x-axis, okay? So our function should look very, very similar to how we drew our end behavior, okay? So that should match with this. And this is our answer. And I can probably do a better job sketching this. So now number 9, we have f of x is equal to x plus 2 quantity squared times x minus 3. So I'm just going to rewrite this as x plus 2 times x plus 2 times x minus 3. Okay, so these are the things I'm going to be focusing on. I have x plus 2 equals 0, x plus 2 equals 0, and x minus 3 equal to 0. So x equals -2, x equals -2, and x equals 3. And notice that we have x equals -2 twice. So we have a double root. That's where the line is going to bounce. Whereas if you have x equals 3, since that's a single root, we are going to cross, okay? So, leading coefficient. This is already factored. If you wanted to FOIL this, you're more than welcome to. But our leading coefficient is a +1, okay? So our leading coefficient is +1. What does that mean? Well, we are going to start up on the right. So it should look like this. For the degree, well, we have an x, x, and x, right? So I'm going to multiply all those x's. We have x times x, which is x cubed. So if the degree of the polynomial is odd, the ends of the graphs will point in the opposite direction. So we have top right, so therefore we have bottom left. Okay, so our degree is odd, so we need to have the opposite of this thing, which is bottom left. Okay, so our end behavior should look like this. Okay, so let's go ahead and plot our zeros, or our x-intercepts, right? So we have -2 and +3. So I'm going to keep note of the fact that we have a double root right here. That's where it's going to bounce. So, because we are applying the wave rules, this little trick here, we always have to start on the right, and we're going to start above the x-axis since the leading coefficient is 1, okay? So, we're going to have something like this. All right, and that's a little too fast, so let me go ahead and slow down. So we're going to start on the right, and we're going to go above the x-axis. As I approach 3, we're going to cross, but as I approach -2, -2 is a double root, it's going to bounce along the x-axis. So our wave should be pointing in opposite directions, just like what we have here. Or I can, again, like I did on the previous one, I can try to make this better. Something like that, right? Okay, moving on to our last problem. We have f of x is equal to -x squared plus 3x plus 10. Now, notice that this function is in standard form, and right off the bat, we have a negative. So I'm going to factor the negative out. So we have negative times x squared minus 3x minus 10. Okay? And I'm going to go ahead on the side over here, draw my x, -10 up top, and then -3 down below. So I'm thinking -5 and +2. So we have negative times x minus 5 times x plus 2. Okay? So, here we go. I have x minus 5 equals 0, x plus 2 equals 0. So x equals 5 and x equals -2. So, that's a single root, and this is a single root. So we're going to cross each time. We don't have a double root, so we're going to cross each time. Okay? So, -2, +5. Let's figure out our end behavior. Okay? So we're going to start off with our leading coefficient. So the leading coefficient is a negative. So we have a -1, and if the leading coefficient is a negative, we're going to go ahead and start down on the right. The degree, well, it's a +2. We don't really need to FOIL this or multiply anything because this is already in standard form and we can look at the degree right off the bat. So the degree of this thing is 2. And this one's different. We were dealing with, odd degrees. This time we're dealing with an even degree. So if the degree of the polynomial is even, the ends of the graph will point in the same direction. So if this is pointing down, then this has to be pointing down as well. But in this case, it's going to be down, left, or left down, however you want to call it. So the end behavior should look like this. Okay? So, remember, we're going to, since we're applying the wave rules, we're going to start on the right, but below the x-axis. So, each of these intercepts, that's where I'm going to cross each time. So here, I should have something like this. And we're basically done.